All right, so let's move from talking about the variables and the hypotheses to what's called levels of measurement. So a level of measurement is the way that a researcher collects data about the variables. And this is important because the level of measurement is going to determine what type of statistics are appropriate to use. So each level of measurement has different statistics that are appropriate. And so it's your job to be able to identify the level of measurement so that you can identify the appropriate statistics to use. So let's break it down into the different major levels. So first of all, there are two types of levels of measurement. There are categorical and numerical. And so categorical items or variables are variables that have answer categories, whereas numerical level variables are variables that have numbers as the response categories. So let's talk about these individually. Let's start with the categorical variables. So categorical variables are variables where the response categories have been set up or predetermined by the researcher. What are some examples of categorical variables? Think about a survey that you may have taken recently and think about the response categories that were given. Was it something where you filled in the blank, or was it something that had options? If it had options, then it's categorical. So for example, most surveys are going to ask you about your sex. Are you male or female? Or if they're being technically correct, they will also have maybe another category. So if the categories are male or female, you have categories. It's not a write-in with a number, it's a category. Same is true for a variable like race, where you would have categories such as white, African American, Hispanic or Latino, Asian, Native American, or other, or any kind of combination. Other categorical variables could be any variable or any question on a survey that asks how strongly you agree with a statement. Do you strongly disagree? Disagree? Are you neutral? Agree or strongly agree? That's another example of a categorical variable. So within this kind of broad type of level of measurement, we have two types of categorical variables. The first are what we call nominal variables. And nominal variables indicate differences among respondents, but there's no hierarchy or rank order implied in those differences. So what I mean by rank or hierarchy is that when you're looking at the response categories, there's no natural or inherent order to those categories. There's no way that they should be. So those categories could be written in any order and they would make just as much sense. So this is the least precise level of measurement, meaning that there aren't as many statistics that you can do with this level of measurement. What are some examples of nominal level variables? Well, one that comes to mind is the variable sex, male or female. Well, oftentimes people will put those categories in that order, male and then female, or they'll put them alphabetically. There's no rank or hierarchy there. Same when we're talking about race. Oftentimes people will put that in order of, alphabetical or what they expect to have the most of, but there's no inherent order to that question. So nominal variables have no inherent rank or order in the categories. So again, you're looking at how people can respond to that survey question in order to determine what is the level of measurement. The second type of categorical variable are ordinal variables. And ordinal variables have categories in which there's some inherent rank, hierarchy, or order to the categories, which makes sense. Ordinal variables order to the categories. So what this means is that we can arrange individuals along some sort of dimension or in some sort of order that naturally makes sense. So what are some examples of ordinal level variables? Well, one that comes to mind is any of those strongly agree to strongly disagree questions, because they have a natural order. It would be strange to see the categories position strongly agree, disagree, neutral, agree, strongly disagree, right? It makes sense to have them in order from least agreeable to most agreeable. So anything that can go from least to most, highest to lowest, that is ordinal. So sometimes we will measure age as an ordinal variable by giving age categories, where we say check the box that corresponds with your age: 18 to 25, 26 to 35, 36 to 45, and so on. That's an ordinal level variable. And this is the second kind of level of measurement in terms of hierarchy. All right, so aside from our categorical variables, we also have another way of kind of dividing these. So there's another kind of classification, and that is whether or not a variable is dichotomous. So dichotomous variables are categorical. They can be nominal or ordinal, and they have only two categories. That's why it's dichotomous. Two category variables. So these are variables that basically they can be a yes or no question, or they can, as long as they just have two categories. So what would be an example of a nominal dichotomous variable? So something that doesn't have any rank or hierarchy and has only two categories. Sex would be an example of a dichotomous nominal variable, or pretty much anything that's a yes or no question is going to be a nominal variable. So what about ordinal dichotomous variables? These are fewer than nominal, but they still exist. So where you have two categories and one comes before the other. So there's some sort of rank to the categories. So under 18, over 18 would be a good example of an ordinal dichotomous variable. So moving on from categorical variables, we have numerical variables. And numerical variables are where data are gathered as numbers, and there's no attempt by the researcher to pre-categorize the answers. And so these tend to be writing questions or where you're just simply typing in a number. So what are some examples of numerical variables? The most common is probably age, or how often do you do something, or how many times do you do something, or how long. Those are examples of numerical variables. So there are two types of numerical variables: ratio and interval. The first type we'll start with is the interval variable. And interval variables are variables that, again, they are numbers. The categories are legitimate numbers. But 0 is not used, or if 0 is used, it doesn't indicate the absence of the characteristic. So there's no true 0 for interval level variables. So what are some examples of interval level variables? One of the most common examples that's given in textbooks is the example of IQ tests. You can't have an IQ of 0. And so simply by virtue of taking the test, you have some sort of score, right? Similar to taking the SAT or the ACT. Simply by taking it, you receive some sort of score. Other examples, the weather. So 0 degrees doesn't mean that there's no weather. 0 degrees is a real number, but it doesn't mean that there's no temperature, right? And so that's what we're talking about with interval variables. There's no absolute 0. So for ratio variables then, it has all the same properties as interval level variables, but there is a true 0. And 0 indicates an absence of the characteristic being measured. So what's an example of a ratio level variable? Well, a ratio level variable could be how many brothers and sisters do you have? Because here, saying that you have 0 brothers and sisters means that you have none, that you are absent of brothers and sisters. So that would be a ratio level variable. For this class, we're pretty much going to treat ratio and interval as the same. In terms of statistics, you can pretty much do exactly the same statistics with all numerical variables, whether they're interval or ratio. But it's important to know the theoretical difference between the two. So if we're looking at the hierarchy or of these variables, if we look at it this way, we can see kind of what are the differences between these different levels of measurement. So along the left-hand side, you have our levels. So you have nominal, ordinal, interval, and ratio. And then you have the characteristics. And so are the categories names? Well, yes, they all have names, even if they're numbers. Those numbers have names attached to them. So nominal are names. Then kind of the second characteristic is there's an inherent order from more to less or higher to lower. And this is where nominal drops out because nominal level variables don't have any rank or order or hierarchy to their categories. But ordinal, interval, and ratio all do. And then our numbers with equal intervals between them. Ordinal is not necessarily numbers, and there aren't necessarily equal intervals between the different categories. But for interval and ratio, that holds true. And then lastly, our numbers that have a theoretical 0 point. Ratio is the only one for which this is true, as that's the difference between interval and ratio. So hopefully you'll find this little table helpful as you're trying to remember our levels of measurement. All right, so there is a hierarchy to the levels of measurement, as I said. Numerical variables are considered the highest level of measurement, and then ordinal variables are below that, and then nominal variables are at the bottom of the hierarchy. Not all statistics are appropriate for all levels of measurement. It's also to remember as a researcher, if you're collecting data on your own, to try and go ahead and use the highest level of measurement possible, because you can always take a numeric variable and turn it into categories later, but you can't take categories and collect data as categories and then divide that out into numbers later on. So for example, with age, we can always take the variable age as measured by how many years, how old are you, and we can then categorize it after we've collected the data. But if we start with categories and ask people simply, what category do you belong in, we can't go back and undo that after we've asked it that way because we don't have that data. So that's something important to keep in mind if you're ever collecting data. One last thing to talk about is whether a variable is discrete or continuous. And this applies to our numeric level variables. A discrete variable is a variable that can be counted in quantities that cannot be reduced to ever smaller units or numbers. So it can't be divided. You can't have halves or pieces of the whole. A continuous variable, though, is something that's being measured as infinitely reducible. And so you can have pieces and portions. So an example of a discrete variable would be number of brothers and sisters, because you can't have half a brother or sister. You either have one or you don't have one. It's not reducible. So those numbers 1, 2, 3, those are discrete. There's no line that connects them. Whereas continuous variables, something like how tall are you? While we typically measure height in feet and inches in the United States, you can reduce that into fractions of an inch and pieces of an inch. So that's the difference between discrete and continuous. And that's the end of our discussion today. Please make sure to complete the Google Doc for today's assignment, and I look forward to seeing you in class on Thursday.